So in previous videos, we've seen how we can adjust the exposure time to adjust the intensity level on the screen, and we've seen how we can collect a background to flat field the image. In this video, I just kind of want to show how we put both of those together. So in this example here, I'm starting with a higher saturation value, about 78, 77% of the maximum intensity. I collect my background. I'm just going to hit SEM area. It collects a background. Again, if we looked at this image processing tab, we'd see we're looking at 2,000 frames. So that's why this takes the amount of time that it does. And then when we're done, I'm going to be able to click around in here to see we see patterns. And what I want you to take away from this is that visually you can see the bands in the pattern. So, you know, what we need to do in the software, if we look at the Huff page and I capture one of these patterns, our software will need to find the position of these bands in the Huff, and we'll talk about that in subsequent videos. But what we're using as an initial guide is, do I see the bands visually? And generally, if we see them visually, then the software is going to be able to find them. So what I want to show next is I'm going to turn off external control, go back to rastering, and I'm going to decrease my my setting here, bring it down to something. Let's go maybe, I'm going to go to maybe 20%, 0.2%. And you can see right now our image processing is still doing my standard backgrounds. If I did my none, I just see that it's a dark image. If I do normalize, I just see that we're looking at we're rastering, so we don't see a pattern. So standard, right now I'm subtracting a brighter background from a darker live image, which is why this turns out to be dark. But when I collect my new SEM area background, then that's going to improve, and we're going to see that now it's going to be flat fielded again. And if I click around, again, you can see that our patterns are still visible. They're just a little bit noisier. And so what we want to be able to do is to say how low of intensity can we go here? And generally what we'll see is we can go pretty low. You know, this is going to go down to about 12%. Again, I'm going to capture a background. We can probably even go lower than this, but that will involve adjusting the beam current. We'll do that as a next step. But here you can see here, visually, I still see that they're a diffraction pattern. So I can go to an even lower value. So what I'm going to do is I'm going to go and adjust the beam current. So I've just adjusted on the microscope. I've dropped it down to, this is about 10 nanoamps of beam current. And I'm going to capture my background. You can see I'm still at this 0.15 milliseconds. I'm getting 6,500 frames per second out of the camera. And you can see this flashing behavior is essentially, we have very low signal level. So when I click, you'll see we see a diffraction pattern, but sometimes we're getting close to subtracting something and getting zero. And that's sometimes where we can go to this custom mode we used earlier. We'll use a division. We won't see as much as that flashing, but we're down at the low end of a signal. And so I'm going to go back to our standard, but you can see visually we still see that pattern. So this is an advantage of the CMOS detector. It's a pretty low noise sensor, and so even at these low intensities, so we're at less than 5% of the dynamic range of the camera, we still get a usable signal that we can collect orientation data from. Now, as far as optimization of this, one feature in the software is this black reference. So if I turn the beam off, turn that off. So now this is essentially setting our baseline, and I hit black reference. That essentially calibrates the camera for a 0 level. And when I turn this back on, I have a signal. I'm going to make sure I don't have external on. I'm going to collect my background again. This makes sure we have the best low-end baseline. So if you're ever trying to work at the lower signal levels, whether that's from low beam current or faster exposure, this will allow you to get the most out of the camera in terms of performance, is to do that black reference. It's never a bad option to do a black reference with the beam off under any condition, but it's more visible when you are when you're working at the lower exposure. So now at this point, I can turn my beam current up now. My signal will improve. You'll see I get higher intensities here. Again, if I collect my background, it will can collect from the full field of view. And if I click around again, we'll see, yeah, I visually see those patterns. I could orientation map from those. So this just gives an idea of how we can visually assess pattern quality. What we would look to avoid is if I turn my beam current down, more, and I'm down at this low end setting, you can see here my value here is at 0.02. If I turn the beam off, I'm essentially still in that range. So at this point is when we would know we don't have enough signal. So I'm going to turn off that, and you can see if I turn and collect my beam with this, because essentially I'm at such a weak signal, I'm looking at this as my low end basement of my signal. I want to be above that, because you can see here, again, it's flashing because it's going to 0. I put on my division, it's still like that. There's just not a lot of signal, but you can see it doesn't take too much before that picks right up to start being above that baseline, and this value starts to come up to see. So generally, I'd probably run whatever that baseline is, try to be at least 2 or 3 times what that lower end value is after a black reference with the beam off, to get an idea of the lowest signal you should run. And if you don't have enough signal, you either need to increase the exposure time or increase the beam current.